What is up, most distinguished patrons of this channel? Today we are going to take a look at two military tanks that I found on the side of the road. And no, I'm not joking about that. I was driving to visit my grandmother to have dinner, and I happened to see these two suckers that you're going to see in this video on the side of the road, and I had to go and investigate them. So that's what we're going to be talking about. Let's get into it. So I drew some cute little arrows so we can all be on the same page about what I'm talking about. Now, this particular Sherman tank appeared to be in pretty good shape, aka they likely sandblasted it, painted it, and cleaned it up a little bit. I don't believe it runs, at least by the look of everything. I doubt it. It looked like it's been where it was for years and years and years, but who knows, maybe it does operate. I'll tell you what, if it did, I'd love to take it for a test drive. Anyways, looking at the welds that are on here, we got a couple different processes, just like all the other Sherman tanks we looked at in previous videos. The red arrow depicts what are sub-arc welds, so machine done. It's a wire process of sorts with granular flux that's separate from the wire that definitely existed and predated the invention of this particular tank. In previous videos, people have suggested that wire welding was used on these, and sub-arc, yes, which is wire, but your standard, say, MIG process or spray arc or even dual shield, none of that existed when this was manufactured. Now, self-shielded flux core actually did exist, sort of as a military secret going back to probably the early 40s. However, that was not used as far as I could tell on tanks. It was all used in the shipbuilding industry. The main reason that was the case was ships themselves often weren't built with high strength alloys like tanks were, like tank armor, and you could use basically wire that was suitable for mild steel more or less on a ship or even parts of a submarine without any issue. But on a tank where you're welding that higher strength alloys, there was no flux core wire that I'm aware of that would have been available in the early 40s to weld them. So it's entirely possible parts of like this Sherman tank, like maybe running gear parts or internal parts, would have been flux core wire welded, but exterior wise, I doubt you're going to ever find any that were, simply because the wire compositions that existed wouldn't have been compatible with the alloy of the armor, and the welds would have cracked, especially if they took a big impact force from like a round that was incoming and hit it. It would have just cracked all the welds. So they had to do something to mitigate that issue. Therefore, they would have used sub-arc as well as like high chromium stick rods in order to weld everything to the exterior. So anyways, the red, like I said, depicts sub-arc. The blue, as far as I could tell, were all stick welds, so some form of faster freezing rod. I mean, again, remember the early 40s, mid 40s, stick rod technology isn't what it is today. I mean, basically, low hydrogen 7018 rods were a military secret in World War II, and definitely were not at the quality of what you can pick up today at your local tractor supply co. So overall, these didn't really look that bad for the most part, given the time frame too. Now, the yellow arrows depict what appeared to be repairs, and I've seen a lot of this. I've seen probably 7 Sherman tanks, and every one of them has kind of like a repair at the same point. And one of the viewers on a previous video had mentioned that it makes sense that the repairs would be near edges. And the reason is that the sub-arc track system probably couldn't reach there properly, so they would end up doing it by hand to connect welds or doing repairs just because it was difficult to make a weld there with the sub-arc machine. That all makes sense, but when you see stuff like that, it's pretty obvious your repairs. And again, looking at all of this stuff, I think that all of these welds are basically original. I doubt that this like was in pieces and somebody fabricated it back together in their garage. It looks too consistent for what you would expect for this type of equipment. One of the interesting things about this particular tank is it appeared to have more like after the factory welded on armor plates than most of the other ones that I saw. And people have commented that the plates on the side were to protect ammo and critical components, which makes total sense because you don't want a whole bunch of weak points on something like a tank where the whole job of it is basically for personnel and equipment protection. And well, if you have some paper thin armor section that's a liability, you do something in the field to fix it. And that's exactly what people have told me these plates were. So they were welded on after the factory. Now, the plate there with the green arrow, the green is for gangster green, as in gangster welds. And what I mean by that is it looks like it's a big giant weave pass, but what that actually is stacked horizontal stringer welds. And you're probably wondering why on earth would they ever do that? Because modern times you don't do stuff like that. You just run vertical up stringers per se. And the reason is simple. Well, one, this tank wasn't tipped on its side when they welded those, so it had to be welded in position. And the rods that they were using, based on the information I have and my own observation, were high in nickel and chromium, and those rods basically don't weld uphill. When you try and weld them uphill, the puddle is so liquid it literally runs like tap water. However, you can progress in an uphill fashion by stacking it like stairs and basically welding on top of a weld and using the previous solidified weld as a shelf. Now, in the future, I'm actually going to do a video where I make replicas of a lot of these tank welds and demonstrate how they were done. And the problem with doing it now is it's the middle of winter, and I don't feel like welding with high chromium, nickel, manganese rods inside of a small tin shed. I mean, that's almost guaranteed lung cancer. It's no joke. Those things are dangerous to be screwing around with, to be pumping your lungs full of the dust and the fume. But anyways, I will do a demonstration on how this works, and it will prove why they did this. And you guys, again, have to remember that this armor that this tank is made out of likely either has high carbon content or some form of an alloy that doesn't like to be welded, aka brought to welding temperature molten metal and then re-solidified fast. And when you just try and use, say, a mild steel rod on this, what'll happen is it's going to crack as the weld cools, and or if it takes an impact force, the weld will fail. So their solution around that problem was to use high chromium, aka stainless, or high nickel rods. And the welds those rods put down does not become brittle like a mild steel rod. So again, they didn't do it that way to put down gangster welds to prove they could do it. It was kind of a necessity. Now, as far as the other welds in here, again, the top of that plate on the side where it's red arrows, that's subarc, and the blue arrows near the top, that I believe is stick welded. I had to look at that in the pictures pretty good because in person people start getting suspicious when you're climbing on stuff like this trying to get pictures. But I believe that whole top area at the bottom of the turret was stick welded. For one, the subarc machine would probably be pretty hard to get in on that kind of an angle. Maybe it's doable, but there appeared to be too many starts and stops, and the beads just looked a little bit different. So I believe that was stick welded with probably 3/16 rods, so big, 2, 3, 400 amp plus rods that you're running on that. Pretty interesting. So again, we see a lot of gangster weaves on this, and like I said, for the previous reasons why they did that, and I didn't mention, that would have been done with stick welding. That's definitely not wire welds, and wire that was high chromium, high nickel didn't even likely exist for self-shielded flux core back in the early 40s or so, so definitely stick welding there for the gangster passes. Anyways, that top turret appears to be a one-piece casting or a big, yeah, it wouldn't have been a forging, but a big casting, and I'll tell you what, that armor plate on the side there, that's pretty thick stuff. I hope they had some kind of a crane or something to lift it up there and some guy wasn't sitting there sweating bullets holding it while the welders tacked it on. That would have been a hell of a chore. And again, that blue arrow to me up close, because I can zoom in on these pictures, definitely appears to be stick welds. I mean, part of it looks like subarc, but man, it's just too inconsistent with too many starts and stops. Just makes sense that they would have arc welded it instead of subarced it. Now, the red arrow depicts what I believe are subarc welds. I'm not positive, but again, wire welding didn't really exist back then, and the welds are too straight, too consistent, and the profile suggests subarc. However, they're a lot smaller, and it's done multiple pass. On the top of the machine and numerous other places, they had big, wide, 2 to 3 inch wide subarc passes, and I'm not exactly sure why here they would have done it as like a set of stringers instead of a single one, because no doubt they could have done that in one shot where the bead would be that wide. Maybe it was some issue with the joint style where they just, I don't know, maybe they'd melt over the corner. Not really sure why they did it that way, but that definitely is not stick welded. Speaking of stick welding, all the blue arrows depict stick welds to me, and those likely were welded in the position that they're in. I don't think that they would have been welding them in a flat position, aka this whole hull was tipped. Like, to me, when you manufacture something like this, you get the big welds to hold the stuff together done, and then you roll it out on an assembly line or out in the parking lot of the factory and just have people go at it with a stick welder and just glue everything together that needs to be put on there after the fact. By the way, if you happen to know what plane that is in the background there, give a shout out in the comments. I didn't read about it and I was in a hurry, and it's pretty cool. Unfortunately, on planes, there aren't very many welds to look at because it's all typically riveted and all the welded parts are internally, and they don't let you in most of those. So maybe in the future, I'll find a way to take a look at some of the welds of the internal structures because they were welded, just not on the exterior. So all of the blue arrows are stick welds, and the red arrow there, kind of on the middle of the hull by that armored plate, that appears to have been sub-arc welded. I'm not positive, just the way it looked in person and in the photos, but it could have been stick welded. I doubt it. Now, the red arrow on the turret, I'm not sure what was used for that because it was basically a giant weld. I don't know that you could have sub-arced something like that in a factory, because odds are whatever factory made this probably got that main gun delivered to them already manufactured, and they weren't putting that together on site. Who knows? I might be wrong on that. But it looked like just a monstrous pass, but I don't know how a sub-arc machine could have been put on something like that. Who knows, but big weld there. And I really get a kick out of those extra armor plates that are on the front of it. I mean, it beats around coming through the hull there. It's basically just a massively thick hunk of armor plate that was welded on the top and the bottom. And I don't know if they were effective. I mean, obviously it might deflect around upwards and save the tank. I don't know if there's any reported history of those actually working, but if it came down to having that or not having it, I think all of us would choose having it. Now, one of the things I'm definitely not sure of is around where I believe is a 50 cal gun or some kind of machine gun came through on the front there. There's a hose or basically a metal line with what appears to be nozzles. And I'm not sure what that was used for. And somebody else asked about that. And I spent a couple minutes on Google, and Google thought I was crazy because it didn't come up with anything for that, no matter how I searched. So I'm not sure what that was. My thought was some kind of fire suppression system, but if that was the case, why would it only be there? So if you happen to know what that was used for, leave it in the comments. You'd be helping me out and a couple people that wondered what that was for. Anyways, back to the welds. The overall welding on this appears to be pretty rough, as would be expected from early 40s, mid 40s technology during World War II. And again, a lot of that comes back to the content of chromium and nickel in those rods that they were likely using, that it's very difficult to make good, clean looking welds with those. It's just the nature of the beast. Now that pink arrow there, I put there just to show the thickness of that armor. Like, that's a monstrous piece of steel, and maybe it was effective, who knows. But again, that was done in the field. That would have never been at the factory. They would have done a little bit different of an engineering job, I think, than a simple plate. But hey, sometimes if it works and it's simple, it's not stupid, right? That red arrow is a sub-arc weld. I'm just not sure why they would have done that in 3 passes instead of one larger one. Maybe the way that the fit up was too poor to do a single pass for some reason. Yeah, pretty interesting. Overall, this Sherman tank, visibly was in good shape. Maybe it does run, I'm not really sure. The overall appearance of it pretty much mimics all of the other Sherman tanks that I've seen at other museums and stuff. And if anything, this was probably the nicer one with a lot more in-field armor upgrades, like that one where the green arrow is. A lot of them that I saw didn't have it on that side. So I don't know. Pretty cool stuff. Well, now let's look at something a little bit newer and compare and contrast. About 100 feet from that Sherman tank happened to be a second tank that was on display, and in the case of this guy, it's an M60. So this is far newer. I mean, you're talking, it says 1965 to 95. Well, that was a service date. I don't know how old this particular tank actually is, but everything that you see on it pretty much tells you that it's a lot more recent than World War II, aka the early to mid 40s. I got a kick out of the weight listed on the plate, which was over 100,000 pounds, and it's pretty amazing to think that something could weigh that much that isn't really that big. When I think of 100,000 pounds, I'm thinking of like big structures and stuff, not something that could be driven possibly on a city street, but I guess all that thick steel really adds up to a monstrous weight. Since we're here in the front of the tank, I want to mention something that I noticed. After doing all these videos for you guys where I look at the old equipment, I noticed that come the, 55s to maybe early 60s, there was a huge shift in the design, overall design of the equipment. And likely that had to do with a lot of what was learned during World War II and immediately afterwards. And when you look at this tank compared to Sherman, the Sherman tank is very narrow, it's very tall. It presents a much easier to hit target, I guess. When you look at this sucker, it's like way wider, it's lower. The front of it's shaped like an axe, where if a round were to hit the front, it's either going to be deflected straight down into the ground or likely upwards. And the profile, it's just so much lower. There isn't a whole bunch of stuff hanging out on the top of the main body that a round could hit. Like there's nowhere that you really need to put armor plate to kind of help deflect rounds. It shows a significant improvement, I guess, in overall design, and likely one that was hard fought and hard won by the failures of Sherman tanks and similar equipment. They learned a better way to do things, better way to manufacture equipment that would last in war. So this picture is very telling, and you can see how rusty a lot of it is. Like the steel is just starting to rust, whatever alloy that is. And then you look at the welds and they look perfectly clean, and that is because they are either a form of stainless or a form of nickel alloy that was used to weld all of that together. So even in the 60s, when technology improved, they still were using similar alloys, due to the nature of the armor that they're welding simply cracking if you were to weld it with mild steel. That would be my guess as to why you still see this. Now, I went and picked up a magnet from a Walgreens down the street and came back here after I had dinner with my grandmother and put it on that weld, and sure enough, very, very low magnetism. So there is no doubt to me that that is either chromium or nickel. Now again, you still see them doing the big gangster weaves, but well, it's more or less a horizontal stringer, and that actually appears to be wire welded and not stick welded. And wire welding, by the time that this tank was produced, did exist. Not only did it exist, the wire with higher nickel or higher chromium would have easily existed at the time, so they could have simply constructed that weld with a more modern welder, aka a wire welding machine. In case you're wondering too, even with wire processes, those high nickel, high chromium, high manganese alloy wires, which are commonly found as forms of hard-facing wires with similar compositions to likely what was used in here, they also have a tap water-like weld pool that will literally run at any inclination of vertical up. So likely they did the same, horizontal stringers because you simply couldn't run a pass uphill. Looking at the turret, this shows a significant redesign over like what you saw at the Shermans in that era, World War II tanks. It's super low. The way everything is positioned on it and the armor plates are welded is to give a very small window that you would actually have to hit a direct hit that would likely enter the turret, aka right around the main gun. Any kind of off-center hit there would be deflected out into the air or the surrounding area. And there's a significant reduction in the amount of welds that are on this tank overall. So a lot of lessons were learned on producing equipment faster by reducing the amount of small parts that needed to be welded together. The red arrow depicts what I believe is a subarc weld. The blue arrows, I believe, actually were stick welded on this. They didn't appear to be wire welded. They definitely appeared to be stick welded. And on something from this vintage, from say the 60s, I wouldn't be too surprised if they did still use stick on numerous welds. It just made sense, I guess. For a vast majority of the construction, they would have used wire on this. Here is part of the carriage and bogie wheel assembly, and everything I saw underneath the sucker really suggested that wire welding was used. Now, based on the weld positions, I believe this was welded upside down and then the whole tank hull was rotated. I do not believe that they welded this vertical up. They likely welded it in the flat position, which with more modern equipment, aka in the 50s, you would have had access likely to bigger, better cranes and more factories. And it just makes sense that they would have welded this in a flat position or near flat versus struggling to run it uphill. But who knows on that? Now, as far as weld composition, I'm not sure if this was a stainless steel weld. I have a feeling that the side armor on this tank might be a different construction than the front. Hard to say on that, but if it is some kind of high alloy armor like the front, then likely these welds also are a form of stainless. All of the orange arrows suggest to me MIG welds or wire welds of some sort. They don't appear to be stick welds, although they still could be. I doubt it. The white arrow is something I found interesting. The suspension on this tank has replaceable individual components that just basically bolt to the hull. And this is a little bit different than a lot of the technology from World War II. And these are probably all standardized, and the repair facility, motor pool, whatever, would have a bunch of them sitting in a box. And if you were to damage one out in combat, or some training exercise for that, you could just drive the tank back if possible and just unbolt it and put a new one on. Mass produced, similar parts or more or less the same part is usable in multiple positions or multiple pieces of equipment just flat out makes sense. It's so much more efficient and cost effective to do things that way. I only took this picture and one more of this particular tank because, well, I had to go and eat dinner with my grandmother and I wasn't about to be late. I couldn't handle the scolding from that anyways. So this is the back end of the tank, and this was pretty interesting as well because clear evidence on the tail lights or whatever, the turn signals that are on there, the housings were MIG welded, and again, a lot of the welds on this thing really suggest more modern technology than anything that we saw from equipment in previous videos from the 40s. And it makes sense because, well, by the mid 50s or so, wire welding was far more prevalent. TIG welding existed, even though, well, we didn't see any TIG welds on this, nor would you expect to. But the technology simply improved. The overall construction design and the quality of everything on this is significantly higher than that Sherman tank we saw earlier in the video. Again, it's 20 to 30-year difference in technology, skill, and just flat out a more skilled workforce was available to build this, and thus the results are far better. And of course, all the mistakes and lessons learned from previous builds all went into the technology behind this. Now, I'm 99% certain that this is a non-running display piece, and that's because these rear engine hatch doors appear to be welded shut all the way around, and probably the worst gangster weave I've seen on any heavy equipment, even stuff done in the 40s as a field repair, don't measure up to how bad the weld was on this. Let's take a look at it. One of the things that's probably most amazing to me about welding is how high of quality welds you can do with very minimal equipment, and how even access to modern technology and modern welding machines, that a lack of skill or simply not caring will produce disastrous, terrible results. Now, in the case of this, that weld does its purpose. Nobody's going to be able to open those doors. And trust me, I tried to find a way to look in there to see what was in there, but I'm pretty sure all the running gear has all been removed because it's probably too valuable, or when this was sold off, maybe at a military auction, it was already removed. Who knows? Anyways, I'm not one to make fun of people's welding ability, but I have a recommendation. If you want to learn to weld not like what you see here, I actually have a video on welding vertical up with stick as well as with MIG. Maybe you should watch it and learn how to do it properly so you can have a lot better results than this. Anyways, sorry for the shameless plug, but this pretty much wraps up the video. Thanks for sticking around. If you got any comments or thoughts on things, feel free to leave them. And the next video on any kind of military equipment I'm going to do is going to be on a German and American submarine. So that'll be a lot of fun. Until next time.